Welcome to our new unit, Chapter 3. This is 3.1. So today we're going to solve two-step equations. So we know that before we used to do one-step equations. We just had something simple like 3x equals 9. So the first thing we did was, well, we're multiplying by 3, so we're going to divide by 3. So the first thing we did was divide both sides by 3, and so x equals 3. Very similarly, if we had addition or subtraction, x minus 4, the opposite of subtracting 4, is to add 4. So the first thing we did was to add 4. And if we add 4 to both sides, we get that x equals 12. We should all know how to do that very easily by now. What we're going to do in this unit is two-step equations. So in a two-step equation, we're going to do two operations. All right, so if you look at the first example that I have here, 3x plus 4 equals 13, we do have two operations. So the goal is always going to be to get the variable by itself. So in most of these instances, we're going to get rid of the constant first. And we know that the constant is just the number by itself. So in this particular example right here, 4 is just sitting here, plus 4 is sitting here all by itself. So the first thing I want to do in this example is subtract 4 from both sides. And if I do that, you see that the 4 goes away and we get 3x plus 0 equals 9. So now we're back to right where we were in the first example. So if 3x equals 9, we're just going to divide both sides by 3 and get x equals 3. This is an example using something called algebra tiles or manipulatives. So what I've done is I've set up a problem right here, and there's a couple of examples in your blend space where you're going to be able to use these too. So you can see that this problem is 3x, so it's 3x, so I have here 1, 2, 3 x's, plus 4, so I've added 1, 2, 3, 4 to this side, and that equals 13. So you can see 4, 12, 13. All right, so what I'm going to do in this particular equation is get the variable by itself. So you can see in this example that I'm actually going to have to get x by itself. If I just look at that, I would say I'm going to take 4 away. I would take these 4 here away from the x's, and we'll start working with that. So if I just take 4 away here, 1, 2, 3, 4, and I take 4 away from this side, let's do this, 1, 2, 3, 4. If I do that, I've taken 4 away from both sides. So if I just come up here, I would have, this would be 0, and this would be 9. So if you can see what I have on my boxes here, I have 1, 2, 3 x's, and I have 3, 6, 9 on this side. So I've kind of lined these up perfectly. Now you see that each x is lined up with a group over here. So I have this x pairs up with this x pairs up with this, and this x pairs up with this. So I've divided my x's by 3, and I've divided my remainder by 3. So 9 divided by 3 is 3, so x equals 3. So we have that for us in our examples that we're going to see in a little bit. So here's another example. Nothing changes for other operations. Again, our goal in this is to get rid of the constant first. It's actually going to be a reversed PEMDAS. We know we used to do the old, p, parentheses, exponents, multiplication, division, addition, and subtraction. And this, when we're doing two-step equations, we have to clear the constant first. And that's usually going to involve addition or subtraction. So we're going to do addition and subtraction first, multiplication and division next, and then we're going to clear the exponents and parentheses. So it's going to be almost reverse PEMDAS if you think about it this way. So let's do the constant first. So in this example, we were subtracting 5. So what's the opposite of subtracting 5? Well, we have to add 5. So add 5 to that example, add 5 to here, and if I rewrite this, we're going to get 2x equals 8. And now we just have to get rid of the coefficient. The coefficient is, of course, the number before the variable. Divide both sides by 2. Divide both sides by 2. X is going to equal 4. So there you have a very simple example of a two-step equation. And the final one I'm going to show you before we get into the blend space is just one example. Let's look down here at problem number 3. All right, here everything is on the right side, so I know you guys don't like it that way, so we're just going to rewrite 2r plus 9 equals 1. And we're going to do reverse PEMDAS. So is there addition or subtraction? We're going to get rid of that first. We want to get rid of the constant first, and then the coefficient. Okay, constant then coefficient. So we'll get rid of the constant. We're adding 9, so we're going to subtract 9. And guess what? Your old friend negative numbers are not going to go away. 2r equals negative 8. So now we have a coefficient of 2, so we're going to divide both sides by 2. And we get r equals negative 4. I wanted to show you an example with a negative number. So they will be there. Pay attention to that as you go through your blend space and all your exercises today.